So on this example, we have in January of 2017, 52% of U.S. senators were Republicans, and the rest were Democrats or independents. 21% of the senators were females, and 47 of the senators were male Republicans. Okay? Here are the two events. We are selecting one of the senators at random, and we're defining R is that they are Republican, and M is that they are male. So the two events that are defined here are Republican and male. Okay? So here's what we're going to have for our two-way table. We're going to have Republican and Republican complement. And then we're going to have male and male complement. We will also have our totals for each of those sections. Okay? So whatever events are defined, you have to write everything in terms of those events. So Republican, Republican complement, male and male complement. It's very tempting to put male and female, but female was not defined here, so we're not going to use that. All right, 100% has to be the total of all of it. Has to all add up to 100%. So now we're going to reread the problem and put things where they go. 52% of U.S. senators were Republican. Where does that go?
That goes in the left column, bottom left.
Our total. Very good. This is 52% total were Republican. So, how many were not Republican or Republican complement? That's 48%. Again, that is Democrats or independents, but in context of what was defined, that is Republican complement. All right, 21% were females. There's no females on here, but there is. It's the male complement, okay? So the male complement total would be 21%. So how many males were there, or what percent was males? 79%. Then it tells us that 47% were male Republicans. Male Republicans. That's where our two events are overlapping. So that's 47%. Now, can you get the other three squares?
Yes.
Sure, let's do it. All right. What is going on in this square on the top in the middle? What is that? Males not Republican. And what percent is that? 32%.
Obviously.
All right. What's going on here in this first column, this right here?
That's that they're Republican, but they're
Republican, but
they're not male.
not male. Very good. And what percent is that?
5.
That's only 5%. And then we have this where R complement and male or M complement come together. And so who are those people? These are not Republicans and they are not male. So
Miss, you got danger. Oh, you erased the whole board, but the answer was 16.
And what percent are in the Republican complement, male complement?
16.
16%. Perfect. All right, you guys. Do you have any question about the table? We're going to turn that table into a Venn diagram now. So you need two circles that overlap. Make sure you have room to write in the middle. Okay. Now we're going to start in the middle. In the middle is where you should always start. That's where you've got your overlap. So this is where your Republican and male overlaps. And so what percent should go into the Republican and male?
47.
That's the 47%. Again, I'm just looking at my table and seeing where Republican and male overlaps there. All right, now I'm going to go to the left. This is my Republican and male complement. These are my Republican and male complement. Literally just look in your table and find where those two symbols intersect and what percent goes there. That's your 5%. All right, on the right.
Sounds like a bird call.
On the right side, we have our males and Republican complement. All right, again, we go to our table, we just see where they intersect, and what percent is that? That's our 32%. Now, we do not have 100% of our chart filled out yet. We need the male complement and Republican complement, which is 16%. So that's how we can go from our two-way table to our Venn diagram. I want you guys to notice real quick that it is the number, it's the numbers that are in the actual chart, not in the totals. So it's just those numbers are now over there. Cool? Cool. So now here's what we're going to do. We're going to find the probability of Republican or male. Now, I have a question for you guys. The people that are in this part of the circle, the 5%, are they Republican or male? They are Republican or male. They fit one of those. The people that are here in the middle, the 47%, are they Republican or male?
Yeah.
Yep. The people that are here, are they Republican or male?
No.
Yeah.
Yes, they are male, so they fit the Republican or male. All right. Are these people Republican or male?
No.
No. So, there you go. If you can answer yes, that they are either Republican or male or both, then you could just add these three numbers up to get your answer.
Why is the middle group?
Say that again.
Why is the middle group also part of that? Because it's Republican and male. It's not Republican or male.
So, if you go to Starbucks and you ask, can I have cream and they ask you, do you want cream or sugar? Can't you answer with both?
Yeah, I guess.
Yep. All right, so what does this all add up to? 84%. Now, there was only one section that you told me no.
Only 84%.
And so, if you look, this is equivalent to 1 minus the probability of not both of them. This would equal the same exact answer.
Which is
1
easier
minus
said as
16.
1 minus 0.16. Yes.
Exactly. So this is the same exact thing. Now, if I use the actual statistical formula for OR, that would be this right here. The probability of Republican or male would be the probability of Republican total there plus the probability of male total minus their overlap, because I would have counted those 47% twice. This is the actual formula for OR, statistically speaking. So, the probability of Republican would be the Republican total, which is 52%. The probability of male is 79%. Obviously, guys, that would be too much, because you have double counted the Republican males. So you have to subtract the 47%. And lo and behold, you still get 84%. There are 3 ways to do an OR problem.
That's a lot more complicated.
There are 3 different ways to do an OR problem. Now, I'm going to show you why this formula is going to come in handy here in just a few minutes. Okay? All right, now that we have our chart, we have our two-way table. The rest of these should be really easy to answer, so let's go ahead and answer the rest of these. Yes?
What do we need to show for the test?
Just show what work you're doing. What calculation are you doing? Yep, you just have to have one of them.
So would the table work?
Yeah, absolutely. All right, consider the event that a randomly selected senator is a female, Democrat, or independent. Write this in symbolic form. What is that in terms of our events that we've defined?
Complement of R and complement of M.
Okay, and so we want to find that probability,
16%.
which we already have in our Venn diagram, and it's simply 16%. Done. Cool?
No.
Not really? I'm sorry.
Group's not right.
Alrighty. Last example. Guys, by the way, this has nothing to do with the Republican male anything. This is a whole different example. So here we go. Suppose event A and B are 2 events such that the probability of A is 30% or 0.3. The probability of B is 0.4 or 40%. The probability of A or B is 0.58. What is the probability of the overlap? How do you go about doing this problem?
Why not just add them up?
Add up what?
Then subtract.
Just add up all of them?
No, you, what's it called? It would be,
This is where the formula is going to come in, because I will tell you that making the Venn diagram is a little tricky if you're not quite sure what the overlap is. Okay, so what we're going to do is we're going to use that formula. The probability of A or B is the probability of A plus the probability of B minus where they overlap. And so I now know 3 of the 4 parts.
Go talk to my counselor.
No. I now know 3 of the 4 parts, and so I can use algebra to solve the 4th part.
Why not?
Because I said it. What is the probability of A or B? 0.58. What is the probability of A? And the probability of B? And we're going to subtract what we don't know. And now we're going to do algebra. So now 0.58 equals, what is 0.3 plus 0.4?
0.7.
0.7. Now we have to subtract the overlap that we are not sure about. And now we just, again, continue to do algebra. And so we have the probability of A and B equals 0.12.